Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at blood flow measurement. In the past couple of videos, we looked at electromagnetic flow meters and we introduced the notion of ultrasonic flow meters. In this video, we will look at one more specific variant of the ultrasonic flow meter, which is the Doppler shift flow meter. What is the principle? Before we move on to the principle, note that the Doppler shift flow meter is quite commonly used in clinics and it can measure velocity, flow rate and direction of flow, and essentially can also be used to image the ultrasound, can also image the vessel. The principle is the following: it works by transmitting or sending ultrasound into the body, and the echoes from the RBCs, from the blood cells, are received, and we measure, because we are the ones who sent the ultrasound. When the received signal and its frequency is measured, the frequency changes with blood flow is critical. So, this shift in the frequency of blood flow essentially gives the speed and direction of blood flow. Before we go to this formula, let us look at something else, that is essentially the following is the principle: the Doppler shift FD divided by the source frequency FO can be described, can be related by their respective frequencies. One is can be related by their respective velocities. One is the velocity of the flow, the other is the velocity of sound itself. Right. This is the target velocity of interest for me. But then there are two shifts that happen in the frequency. What are the two shifts that happen? One that happens between the transducer and the cell, the other that happens between the cell and the receiver. There are two that happens. So, I could essentially describe this as FD by FO is 2U divided by C plus U. But then this is approximately 2U divided by C. Why? Because C is much greater than U. For example, C is approximately 1500 meter per second, whereas U is approximately, what is the approximate blood flow? It's about high rate, is about 1.5 meter per second, the high rate, right. So, this is FD by FD by FO is essentially 2U divided by C. Approximation is an approximation. But then velocity does not act along the same line. There will be an angle factor that will come into this picture, and that angle factor is what is included in this formula, where capital F is the frequency shift, U is the velocity of flow, and cos theta is the angle of inclination, F is the source frequency and C is the speed of sound. Now, you know what is the frequency shift that happens and the angle effect that comes into the picture. This is because the velocity does not act in the same line. There will be a slope. So, the precise angle theta is then required for computing velocity. So, the Doppler signal, if you measure, will be 0 when the probe is positioned at 90 degrees to the flow. Why is that? Because cos 90 is 0. You need to find a way to shift the probe to locate this spot, then you know if that is 90, then depending on that you can estimate what the other angles are and modify the angle. So, when will the minimum Doppler shift happen? That will happen when the angle is 90 degrees, is it not? So, when the probe is positioned at right angle, minimum Doppler shift will happen. Now, there are different types of this Doppler meters, continuous wave Doppler devices. The continuous wave Doppler device uses continuous wave ultrasound between 3 and 10 megahertz, specifically special materials, piezoelectric crystals, transmits and captures the sound. What are these? Lead zirconate, titanate for example. And the Doppler shift results from the backscattered signals from the moving red blood cells or blood cells. Now, output signal essentially is a range of speeds or a speed profile, that is. With this, we come to the end of this video. In this video, we looked at the principle of operation of the Doppler shift flow meters. We will continue our discussion on other types of flow meters in the upcoming videos. With this, we end this video. Thank you very much for your attention.